Okay, this was the last slide that we stopped on. I'm going to wrap up that lecture, and we're going to move on to some other bread and butter stuff that is associated with what I call the modern type of telecommunications. Um, okay, let's go here. All right, so just a reminder, as well, I would encourage you to keep that slide, record that image, capture that image. This image from the downloaded, it's going to be clearer from the downloaded materials. And have it on your cell phone, excuse me. So have it on your cell phone all the time, because if you get a job, or even if you don't, there's no way to escape this IT part or the infrastructure part in our daily lives. This is how the technology is evolving. So it's part of us, and we're part of it right now. So some of the highlights from this particular slide would be, notice, okay, Cat5 is pretty much obsolete now. You will still see some of the older existing installations, but you're going to see it less and less. Learn how to see it. How do you see it? How do you recognize Cat5? Well, every so often, every so many feet, there is going to be an imprint or stamp on the cable itself, and it's going to say Cat5. And if it doesn't say Cat5e, it is Cat5 without the E, all right? And it's capable of only 100 megabits per second. And just as a reminder, when we are talking about speed, we're talking bits per second, megabits per second, kilobits per second, gigabits per second, and so on. When we are talking about storage, like hard drive storage or jump drive storage, we're talking about bytes. And the byte is 8 bits. A bit is just a kind of a one piece of information, one digital, one digital digit. All right, so we're talking megabits per second. So Cat 500 and VoIP telephone system will not work on Cat 5 anymore. It's not anymore. It won't. The lowest possible cable that the VoIP system is going to work on is going to be Cat 5e. Is it going to work on Cat 6? Yeah, okay. But no lower than Cat 5e. And with time, you're going to learn how to see it just from a distance. Cat 5, it looks slightly, it looks like almost like an old cabling comparing to Cat 5e. So when you walk by and you're doing kind of a survey, and survey is, you're going there with your notes, with your notepad, and making notes, pre-installation notes or pre-quoting, pre-assessment notes on what the facility is at, what's the status of the facility as far as the technology that concerns you. What needs to be replaced, what needs to be added, and any kind of obstacles that you would go, and you need to have some maybe additional equipment to do any kind of jobs. All that basically is either included in the quote or considered when preparing a quote. A survey can last an hour, a survey can last 2 hours, it can last a week, depending on the project that you're doing. And a good quote depends on the survey. And the profit margin depends on the quote. Sometimes if it's a big project, if you misquote that, you can actually put the company under. I mean, the company you were working for. If it's yours, then it'll be your company. All right. So, Cat 5e, look. Go back to this slide. Let's go back to the slide here. 1 gigabit per second, up to 300 feet. We're not concerned about that bandwidth because when we are doing the data infrastructure, we are working on this side of the modem. That side of the modem is the outside, and the internet is provided to us in analog form. On this inside side of the modem, we're talking about digital signal format, and we're talking transfer speed. We're not interested in bandwidth, although we do have the information here. Now, what I want you to really get out of this one here is sometimes you're going to be standing in front of a dilemma, whether to use Cat5e or Cat6. Is Cat6 better? Yes, Cat6 is better. Well, well, look, 6 is more than 5, so it must be better, right? And it's the later generation than Cat5e. So, well, and the client can pay some considerable bigger amount of money. But here's what you need to know, and what maybe possibly relay that information to the client. Client wants Cat6 because it's better. More expensive, okay, well, so be it. But look at this thing here. Why? Because Cat6 can carry 10 gigabits per second instead of 1 gigabit per second. Wow. But here is the whole trick about this whole thing. Up to 180 feet. And if the distance end to end, and trust me, the distance accumulates quite quickly in a medium-sized office, because the cables are going up, down, left, right, and down again, whatever, the distance of the cable just grows quickly. So if the distance of the end-to-end link is more than 180 feet, why would the client pay for Cat6 if all you get is 1 gigabit per second, which would be Cat5e? So you might as well pay less money and get the same results. If you really, really want, because sometimes you need that 10 gigabits per second, especially when things like Citrix systems. And Citrix system is basically, instead of the software being fired up or fired or started or installed on the local PC, like for example, well, let's say Excel or Word, then if it's a locally installed software, then it's going to be installed on the PC that you're working on, and when you click that icon, the software starts that is installed on your computer. Quite often companies are switching to something that's called Citrix, or sort of like that systems, is that the software does not live on the computer you're working on. It lives in the main server, in the LAN room. And the computer that you're working on is just a display of that software that is fired up on the main server. So that means you're going to have a lot of information, visual information and data going through that cable, because your computer has to display all that, and everything happens through that cable. So that means you're going to need a little bit bigger, transfer speed, or faster transfer speed, so the system is not slowing down with the displaying of the information and all the data. Why people do that? Why do companies do that? It's a cost savings. It costs less money to install one piece of software on the main server and buy whatever a number of licenses for people to tap into that software and fire up those sessions, than to install the software locally on the computer. It's all about money, right? So that means you're going to spend more money on the infrastructure. So in that case, if you need up to 300 feet for the whole office, and if you just want to, okay, I need 10 gigabits all across the board. Some of the PCs are close to the LAN room. Some of the PCs are further away from the LAN room, and some of them, yes, they do exceed 180 feet of a total cable run. Then you're going to have to get Cat6a, and it's way more expensive to buy that cable. It's way more expensive to install that cable, and it's way more expensive to perform the terminations and actually troubleshooting and testing, because different equipment is going to be involved when testing, troubleshooting, and actual installation and termination of Cat6a. All right, everything is more expensive. Even the connectors themselves are more expensive. Right? But that's the story here. Cat5e is the working horse of whatever the industry is right now. It's still going strong. For the most part, Cat5e is the copper link of choice. And then Cat6, if you want 1 gigabit, if you want 10 gigabits per second, And if your computers are close enough to the LAN room, yes, go for it. You're going to get the benefits of 10 gigabits. And then what I just said. Then Cat7 and it's, anything after Cat6a, the general perception is that you might want to consider, fiber link between instead of copper. So, okay, so that's in a nutshell as far as that. So keep that slide. All right, T568 wiring detail. All right, this is how we count the pins on a plug. And if you're plugging it into the jack, then the pins are going to correspond to the pins in the jack, the prongs. Right? There you go. If we position it like this with the latching clip, that's on the other side, and the prongs are this way here, then we're counting the pins from left to right, or in this case from bottom to the top, right? Depending how you turn it. So 1, 2, 3, 4, 5, 6, 7, 8, just like that. Just like that, we're counting the pins. This is not how we count the pairs. The pairs we count, let's see here. Here's the pins. 1, 2, 3. Okay, this is kind of going a little bit different, but you should be able to transfer that thing directionally. All right, so here are pins 1, 2, 3, 4, 5, 6, 7, 8. And you see here, remember, blue, orange, green, brown. These are the pairs, the first 4 pairs of the 25 pair color code. And here are the pins 1, 2, 3, 4, 5, 6, 7, 8. And here are the pairs. First pair, blue. The blue takes the 2 middle prongs, 2 middle pins. Right in the middle, smack in the middle, is a blue pair. And this is how it is being installed, with the solid blue here and stripe, the group color over here. So pin 4 and pin 5, see that? The 2 middle prongs, 2 middle pins. Then remember the dance that we did? Blue, orange, and then green and brown, all right? T568A. So blue, orange hugs the blue, and extreme one side is going to be the green pair, and extreme the other side is going to be the brown pair. And this is the polarity of solid versus stripes. Over here, what we do here, what we have is T568B, as in Bravo. There. T568B. Okay, well, the blues are where they used to be. The browns were where they used to be, see? And the oranges and greens are crisscrossed. Where green used to be, now it's orange. Where orange used to be is greens. Now, up to Cat 5e. Up to Cat 5e. Right here. Only 2 pairs are being used, which is greens and oranges. One is transmit, one is receive, which one is which, depending on which side of the cable you're looking at. Now, when it comes to Cat 6 and up, well, I'm pointing down, but up as a category, all 4 pairs are being used. So the blues and the browns are also being used, Cat 6 and further. All right, so let's see here. That's why this is a scheme or schematic, or this is a way of terminating Cat 5e, and if you want to well, that's what basically looks like. All right. In fact, in some of the when you see some of the less expensive patch cords or the connecting cables, when they are spec'd for Cat 5e, Sometimes you're going to see a jack like this and a jack like that, or a plug in the cable, and the prongs in the plugs, those two middle prongs and pins 7 and 8, are going to actually be missing any kind of conductor, and the cable is going to look lighter and more flimsy because you're going to have only greens and oranges there. That's it. Cat5e. What do we have here? NIC, MDI. Right? NIC stands for Network Interface Card. Add the PC. And that's for the medium dependent interface. What's the medium? Well, copper, a cable. And what do we have on the other side? Hub or a switch. Medium dependent interface. So if you really want to know which is transmit, which is receive, at the PC side, the greens are going to be transmit and the orange is going to be receive. And if you go to the other side, of course, the directionability is going to be corresponding. All right, here's a mouthful. And this is considered a straight Ethernet link. Things are going pin to pin. Now, the port in a hub or a switch is wired in such way that is going to receive the signal in this form. This here is wired to receive, and it's waiting for a transmit signal. This pair here is wired to transmit into the receiving pair of the PC, on the PC side. Straight link. All right. Then why do we have this? So that we're going to have, whoa, look at this. We're crisscrossing. All right. Now, in one case, in this case here, this port is wired, or this jack or plug is wired in an A configuration, and this one here is wired in the B configuration. Where the oranges used to be, the greens are, and where greens used to be, the oranges are here. Right? It is not going to work if you plug things into the switch from a PC to switch, because you will be connecting transmit pair to a transmit pair and receive pair to receive pair here. But if you need to connect two PCs together, then you're going to have to get a crossover cable. So the transmit is going to, because the two network interface cards, PC to PC or laptop to laptop, if for whatever reason you want to connect them, you're going to have to wire them so the transmit pair is going to see the receive pair. So you're going to have to crisscross because those ports are identical. And if you don't use a crossover cable, you're going to connect, you will be connecting transmit pair to transmit pair and receive pair. There will be no communications. Up to Cat5e, it works like that. Next the slide there. All right, so remember this thing here when we did the testing? This is the reason why I wanted you to wire one of our links. And we just chose, it just happened to be the toolless because it was easier to wire. And we had those test results. Does this remind you of something? Excuse me. Here are the pins. And here's a shield, if there's a shielded cable, but we were using UTP, unshielded twisted pair, so the shield is not used. That's fine. And you see, the blues are going straight. The browns are going straight. Pin 7 and 8, pin 7 and 8. And the oranges are crisscrossed with the greens. See? All right. I just wanted you to look at, I told you we were going to analyze that pattern, and that's the time is now, all right, to analyze this pattern. So here you go. We're analyzing this pattern. Happy? Okay, good. All right, next is the slide, please. Now, when you Google things, and if you punch in Google crossover data link or Ethernet crossover link, something like that, and you click images, sometimes you're going to see something like this. something like that. And sometimes you're going to see the blues and browns going straight. And sometimes you're going to see something like this, where you see the oranges and greens are being switched. Yeah. But also the blues and the browns are being switched. And then and both of those are going to be called, those images are going to be called crossover Ethernet link. And if you're wondering, what is happening here? Did somebody make a mistake? Did somebody... No. It's not them, it's you. All right. Because you don't know. And now you know. What do you know? Well, you know this. Cat6 and up, all 4 pairs are being used for the data communication. As opposed to Cat5e, only 2 pairs are being used, oranges and greens. Cat6 and up, blues and oranges and greens are being used, as well as the blues and browns are being used. So you got almost like doubling the channel, the throughput. Well, then if that's the case, then if we want to make a crossover cable, we not only need to switch the greens and oranges, we also need to switch the blues and the browns, because they are the equally playing partners in that in this scenario here. So if you were wondering why you get 2 different images and both of them are going to be labeled crossover cables, now you know why. Some of them are up to Cat5e only, and some of them are going to be Cat6, and sometimes these things are not being explained. All right. Okay. And that was the last slide from that presentation. Let's just quickly go. And we're going to start up something new here. There you go. We're going to talk, I'm going to introduce you to a certain type of equipment that you're going to be working with if you get a job in this field. And this field is so vast, I can only show you a little bit. I can only show you the, well, as I described, I can tell you that the bells are ringing, okay? Now, later on, as you go along, you're going to not only know that the bells are ringing, but you will be able to pinpoint the church that the bells are ringing at, okay? Kind of a metaphoric statement, but hey, it's Friday. So we're talking about the security, fire, and surveillance. We'll start with the security, well, security alarms. Surveillance is part of the security system, so is fire, but security is security alarms. All right. Excuse me. I'm going to, when you download this, it's already available for downloading for our class on 2024. Network cabling, ELEC 1013. Fanshawe College. All right, so click on those links, and that's going to give you a little bit more, well, tasting platter type of presentation of what is what. Right? I'm not going to go through that. You can do it yourself. And if you don't have that downloaded document because you're watching this thing 5 years later, this is what? March 1st, 2024. This is when this thing is recorded. Then you can just type this whole thing, and if this thing is still up, you can see it. All right. Main board example of, well, typical security alarm. Let's analyze things a little bit, shall we? Here we have the termination strips. This is all the circuitry that goes blibbity-blab, blibbity-blab, you know. It just works that way. Here is the memory battery. Here are some terminals. We'll talk about those later. There's a serial terminal. There is a memory key, which is very rarely used, although in some of them. And there's some other terminals that are less used. These are always used. Here is the battery, backup battery connection, and the charging circuitry associated with the backup battery, because the backup battery has to be recharged. on the same basis, just like the car battery. All right, let's take a closer look at these here. Here we have the AC part, bell, program, relay, auxiliary, bus, and zones, and the communicator part. These two here, that's how you power up the system. 2 screw terminals. AC, notice there is no polarity because it's AC. 18 volts AC. A doorbell transformer will power this up. In fact, most of the time, we do get doorbell transformers to power this up. Or you can get a specific plug-in transformer. If you don't want to wire up the transformer into the electrical panel, you can get a plug-in transformer with AC outputs. But I just thought I would let you know that when you get those plug-in transformers, they are fused inside. They have fuse, and you don't have access to that. There's no way of taking this thing apart. If you short those 2 terminals on the power supply, you gotta get a new power supply because that thing is quite sealed. All right, so that's where you plug in the AC. Over here are those screw terminals. It says bell, and then we have plus and minus. That means, well, what does that mean? Bell is a siren. It looks like a speaker horn, paging horn, but it's not. It's just a tone generating siren, and those damn things are loud. And the sound is designed that while you're in close proximity with this device, it will be very extremely uncomfortable for you. Right? So when the alarm goes off, when the alarm is armed to watch for the intruders, and somebody triggers the alarm, you're going to have 12 volts appear on these terminals here. And the alarm siren is designed that if it sees 12 volts on its terminals, it is going to it's going to go crazy with the noise. That's what it's supposed to do. All right. Now here we have program and relay contacts, and here's a common. These common are the same point. Here's a common as well. It's like a ground reference for the sensing circuitry and whatnot. 1, 2, 3, and 4. This particular board has 4 program terminals, and you're going to have to, if you are going to install these systems, you should familiarize yourself with them. So there's going to be some reading and maybe watching some videos presented by the company who sells that, or maybe participating in some live training. Because those things like this type of equipment is not available for general public. It's available through the distributors that don't sell to public, that sell to the businesses that do install these things. It's just that the economy just works that way. And the companies who sell or who produce this type of thing, I say thing a lot. This equipment, they want to sell as much as possible. So they are in good relationship with the distributors. And distributor is basically a store, but not for public, not for general public. And they organize training sessions, because the more installers know how to install them, the more equipment they're going to be able to sell. It just works that way. But I'm going to tell you this. In this particular system, if you program, okay, these 4 terminals are programmable through the programming section, and you use laptop to program this one here. Yes, you can program this thing through keypad, but you don't want to program this thing through keypad. It's just laptop much better. Connectors with laptop, and you have the graphic interface, and much easier and actually possible to do business. But I digress. 1, 2, 3, and 4 program buttons or buttons, program terminals. They can be programmed to be triggered based on whatever condition. For example, if alarm condition, then activate program terminal number 1. If the system is armed, then activate this one. If something else happens, if somebody walks through the door, activate that. All right. How these work, they are pretty much floating in the air. And I think these ones here, if activated, they get connected straight to ground. So the other some of them are connected to ground, and the other cable has to be connected to the positive side of the auxiliary here. Or some of them are going to be connected to positive, and you're going to get the other one wire connected to the common. Different companies produce it different ways. You got to familiarize yourself with how this particular board works. Then you have a relay contact. In this one here, you have common, normally closed, normally open. So it looks like it's a single pole double throw relay. If the pole touches this one, then you get this normally closed. So normally if it's de-energized at the idle state, the common and normally closed, you're going to be connected internally. If you activate the relay, then you're going to have that disconnected from the common, and this one, these two are going to be connected. That contact relay also can be programmed to be activated based on certain alarm or status conditions. Yeah. Moving on, we have auxiliary terminals. This is an output. See, here's power. And here's power, but this is the power that is being provided to the whole system, so it works. It's also complemented by these terminals, which is the backup battery. If the power goes down, then the backup battery kicks in, providing power for a certain amount of time. And some of the clients would say, okay, how long do we have with this battery? How long do we have? I don't know. You can never tell, depending on how many active devices you have, how many motion sensors you have, how many keypads you have, how many other peripherals you have that need to be powered. And then if more current is being drawn, then it's going to stay less time. But pretty much on the average, you get about an hour of power outage, and the alarm system still going to be powered on its own through its own backup battery. But don't quote me on that, because you say, oh yeah, Bach said an hour, so we have an hour. It's no guarantee. Sometimes it's 20 minutes, depending on the condition of the battery. Sometimes you don't have any time because the battery is weak and somebody didn't bother to replace it. And hey, all right. So this is the power that comes out of this board to supply active devices with power. Active devices such as motion sensors, glass break sensors, keypads, sometimes even maybe expansion boards or other peripherals. Now, this is not an endless source of power. You gotta read the specifications of whatever equipment you have at hand to see what's the capability, what's the voltage, what's the amperage or ampacity or amperage of this power supply. Because ampacity is ability to carry current by a conductor. But amperage is the ability to provide current by the power supply. So sometimes when you get too many motion sensors or too many whatever, it adds up. So not only you have to read the ability for this to provide the current and still stay at the 12 volts that is spec'd for. And you also need to read the specifications of whatever the device or devices you're installing, such as motion sensors, keypads, glass break detectors, and other peripherals. You gotta be able to tell and read the specs on how much power those things are draining. And then you can actually measure using an ohm meter. Plug the ohm meter right in there, right in series with the rest of the circuits. So you're going to get a bunch of wires with the power to whatever to whatever devices, and you're going to get all the red ones and all the black ones combined, and you're going to make a pigtail, and just going to tap this one here and tap the other one here, and there you go. You have power provided to all the devices. You can disconnect one and put ohm meter in series and say, okay, well, it's draining so many amps or whatever, and you're going to look at the specifications of the board. Is that supposed to be providing that many amps that this whatever the overall load is, equivalent load of the whole thing, draining? All right, but I don't want to repeat myself. Let's go. Here's the bus. Okay, look, this was in green and yellow. Something that's called a quad cable is usually used to wire up the devices in security alarms. And the quad cable uses the old color code: red, green, black, and yellow. Except, as opposed to telephony, we're not using the red, green, and black and yellow. We're using black and red out of this 4, and quad because it's 4 conductors. We're using black and red for the power, and we're using green and yellow for signal or contacts on the passive devices, such as door contact. And it says bus. Well, that's because if you have smart active devices, because motion sensor is active device, but it is not smart in a way that it actually communicates with the board. I'm talking about the classic example. If somebody say, oh, but I know a security alarm that has smart motions. Okay, maybe, all right, sure. I'm sure there are some existing. I'm talking about the regular classic kind of a setup here for alarm system. All right. So the smart active devices such as keypad would have the power connected to it, and it would have the green and yellow. So it would be black and red, sorry, red and black, and then green and yellow. So, and they will be connected. And sometimes on the keypads, it's just going to say black, red, yellow, and green or whatever. And it's just going to match the conductors to the colors that it says. Or sometimes it's going to be labeled as just as like this. Right? And since they are common devices, so power is going to be just distributed parallelly to all of them. And so it is going to be the bus, because it's a bus configuration. So you're going to connect green and yellow to the first keypad, and then parallel connection, just tap off of that and continue. Next keypad, tap off parallelly, and the next one, because it's a bus system, so everything taps into that pair, green and yellow. Right? Next, we go here. We have the terminal strip for the zones. We have to be able to connect some of the devices. For the most part, it works like this. You got common, and you got common, and you got common here. Every once in a while, you're going to have the common. These are the same terminals. This one here electrically, actually physically is connected to that one. It's just those common points are distributed for easy access if you go further along, right? And here's zone. This one here, this board is capable of 8 zones. 1, 2, 3, 4, see, 5, 6, 7, 8. A zone is a circuit that the alarm only it cares if it is closed or open. In some cases, it wants to see a certain type of resistance if it's programmed that way. Provide extra security or extra zoning. But let's take one thing at a time. If the zone is activated and programmed as normally closed, then it is just enough to put wire from here to here. And if you arm the system, it is going to monitor those constantly to see if somebody didn't cut the wire, but that would not be very useful as far as alarm system, right? Well, what do we do here? We run a cable, and the green, if it's a door contact, which is not using power, we're going to use just the green and yellow pair connected to the door contact. And the door contact could be a surface mount or it could be flash mounted in the frame. It's a reed type of contact, reed, as just like the reed in a saxophone mouthpiece. It's the shape of a switch. And when you bring a magnet too close to the reed switch, the switch closes. You take the magnet out of range and the switch opens. All right. So on a door frame, you could install the switch because it has to be wired, so it will be on the door frame. And on the door itself, you can mount a magnet. So if you close the door, you're going to bring the magnet close to the switch, and it's going to. That's how the door contacts work for the most part. And if you connect that to the zone, then the zone is going to see if the circuit is closed or open. And depending on what it is, it's going to either go into the alarm state or not. It has to be armed in order to go into alarm state. So let's say usually, zone 1 is being installed on the main entrance, right by the keypad. Zone 2 could be, for example, all the windows in the living room. And you'll be connecting them in series. So from that zone 2 to one window, and then in series to another window, in series to another window, let's say 3 windows, and then you're going to come back into common. So you're going to have a loop of 3 windows connected to zone 2, and you can label that zone living room windows. Zone 3 could be, I'm just grabbing the ideas from the air. Well, it could be downstairs motion sensors. You're doubling up some of the sensors, because if you wanted to, yes, it's possible to have a zone designated for each and single device, but you're going to run out of zones. Zone 4 could be downstairs glass break detectors, and so on. You can, once you have the house, residential, small business, or bigger businesses, you can work out those zones. This is for a small business / residential type of board. Only 8 zones. It is expandable to many more zones, but you need to get expansion boards and such, and things like that. All right, and then over here, we do have a communicator. Oh, look. Here's tip and ring. And here's tip 1 and ring 1. What's up with that? Tip and ring. Oh, wait a second. We've heard it somewhere. Oh, POTS. Plain old telephone service. The most basic telephone line. Up till not too long ago, this was one of the most popular ways of connecting, because everybody had the phone. Now, not so much. Still, sometimes it is less expensive to just order a telephone line for the business part. How does that work if it's working on POTS? Well, you get to the point that the telephone signal is being brought in from outside, and then it's being redistributed to the rest of the house. You interrupt that connection, and before the telephone line gets out to the rest of the house, straight from the city, straight from outside, you connect this telephone line to the tip and ring here. And then you continue from tip 1 and ring 1 to the rest of the facility, of the building where the phone is installed. What does that accomplish? Well, it's a security alarm. If something happens, the security alarm needs to communicate with the monitoring station. By the way, security alarms are not connected to police. Nothing is connected to police of that sort. Things of this sort, alarm systems, fire alarm systems, and all that stuff, is being connected to something that's called monitoring stations. Monitoring stations provide service of monitoring security alarms, surveillance alarms, and whatever else has to do with security. Well, you set up an account with them, you pay the money fee monthly, and you get, for that, in return, you get the monitoring service. So what happens? You get the phone line connected straight to this alarm, and later on, so the phone line has to pass through the security alarm. In the event of alarm, this alarm system is going to steal the telephone line, is going to disconnect the rest of the house, grab the line, hang up if it needs to reestablish the dial tone, pick it up again, dial the number that is programmed for the monitoring station, communicate the messages, blah, blah, blah. Okay, here's, my name, or my number is so-and-so, and they will be having the record of that in their computer systems. And it's going to communicate alarm, so-and-so time, zone 135, right? And the monitoring station will have the nodes automatically inputted into their system. That zone 1 was the front entrance, or let's say 2, 5, and 7. So zone 2 is living room windows, and then glass break detectors, and then motion sensors. And you see no front door being opened. So the people at the monitoring station go, oh, something could be up. Nobody entered the front door. Seems like the glass break detector went off, and the motion sensor went off. Okay, so they will have the instructions of calling the police. So the police is being called by the monitoring stations. Okay, and if you're interested in business like that, installing security alarms, talk to me. I'll point you into the right direction, including I'll give you some addresses and contacts for some monitoring stations so you can establish contacts with them and you can actually make money, monthly residual income. Right? If something like that appeals to you, talk to me. Let me know. All right, so we just went across that here. Quickly before I let you go, here's a serial interface port in this particular one. Some other ones may have them in different spell, but through the interface serial port, you buy a physical jig from the same company that sells the alarm. It's a serial interface. You plug that thing into your USB of your laptop, and the other part is going to be plugged in here, and that's how you establish the communication between your laptop and this security alarm. And that's when you can do the programming through the software that you have to install on your laptop. But what else you can do is you can buy something that's called a Ethernet interface or IP interface. It looks like about this size. See, this is a watch battery here, about that size here, box. On one side, it plugs into the serial interface here, serial port, and on the other side, that box has an Ethernet jack, so you can plug this thing into the network. And in this case, all you have to do is plug in your computer or a laptop to the network and establish connection with this security alarm through the network. And the monitoring would be not done through the phone line, it's going to go through the network system. Or some of the alarm systems, they have monitoring our communication with the outside world established through cell phone modules. But then again, you have to buy the cell phone module and you have to purchase the cell phone service for the particular security alarm. Okay, now it depends how secure you want to be, and there's always, well, there's never a guarantee that the security alarm is going to prevent the theft, but it can provide, well, a huge obstacle for the people who are no good. Yeah, they're bad. No good is bad. All right, cool. So I'm going to stop here, and we're going to continue that next week. And just don't forget, I'm going to release the test. Is it test number 2? This week. I'm going to release it this weekend, so we're going to have maybe part of this weekend as a bonus, but I'll give you a whole week to complete that one on the same basis that we always do. All right, happy Friday, everyone, and enjoy your weekend. Well, it's like 8 degrees right now today. In the morning was -7, so the weather is going crazy. Have a good weekend. Thank you, and I will see you. I'll see you next week. Thank you. All right, hey, okay.